Okay. So I'll go as Jeff Pulver. So JEFFPULVER.
Okay. And what's your title here?
My title is Director of Research and Innovation, or the Research and Innovation Office.
Okay, cool. Yeah. And so the whole interview, you'll just talk to me.
Okay.
Don't worry about the camera at all.
Ignore me.
Yeah, just ignore that.
I'm not here.
You talk the way you talk. So if you're a hand talker like I am, it's fine to do that. If you want to put your elbow on the table, that's actually great. That looks really good. Because that'll also, the one thing I will ask you though, is watch
this pivoting.
Yeah, watch the pivoting.
Okay.
It's hard. And I don't know if you can lock these. I don't think you can. But that's the only thing. Other than that, if you talk the way you do.
Okay.
That's it. You good, Ray?
I'm good.
Okay. So we'll start at the very top, at the beginning of the story. The Maine DOT has moved into this sort of systemic way of looking at its roadway system. And if people don't have any idea what that is, talk to me at the very high level. What is a systemic approach to safety?
Well, a systemic approach to safety from a countermeasure perspective is when you take a safety improvement and you apply it over a whole bunch of locations that have similar attributes, so that you're not doing a spot location improvement, but you may be making a less of an improvement on a single location, but spreading that money out over tons of locations, and if you add all that up, you get a large benefit. So it could be something like stop ahead pavement markings, and we're going to do it at 200 locations, and they're going to be a small percentage reduction, but when you add that up, it makes a big difference.
And so when you say that is impressive, but it's even more impressive because it's proactive, right? So talk to me about the traditional sort of reactive versus this approach.
Sure, and there's a few ways to look at the proactive versus reactive. One way is looking at places where crashes don't happen at all, where you have certain conflict points. You look at a conflict diagram or a kinetic energy diagram, and you see the way the vehicles could interact here. You see the certain risks that are going on. Some of the things that we look at are the speed of the posted speed limit of the major road, the intersection control, like is it signalized, does it always stop, is it a free control on the primary road. Those are all have certain risks to them. So you can look at that at just the risks. And then there's the traditional way of looking at it as just the result of the crash. How many crashes are there? How frequent are they based on, the number of vehicles going through this intersection? And then you have some sort of a crash rate, and that's the end of the story. And a lot of internationally, some states have been moving towards looking at the severity of the crash. So where did this actually end up? Did it end up as a fatal or serious injury? And then, plotting locations and prioritizing them based on what actually happened, the end result, fatal or serious injury. But there's a lot of hesitancy to do that for a lot of agencies because of what's known as chasing fatals, where a fatal crash happens at an intersection that doesn't necessarily have a lot of other issues or a lot of patterns to go with that. And then something suddenly comes to the top of the list. It becomes, high importance. It gets in the news. It becomes a priority over other things that, maybe safety engineers are more concerned about. And what we wanted to do is we wanted a way to connect kind of what's happening with real crashes, what's happening with fatal and serious injuries, what's that fatal and serious injury risk of the crashes that were there, as well as, in that kind of pulling in a way, the kinetic energy diagram, seeing where the people collided, how they collided, what angle, what speed, and kind of merging that all into one method.
And so the idea is to clearly you're using crash history because that gives you the sort of metrics that you then apply to other locations. But the whole goal is to prevent crashes.
Sure. Yeah. Yes, crash history is actually a part of this, and that might be controversial for some states because a lot of people have moved in a very proactive way where crash history is not included at all. But, we do have an issue with that in some ways. There are certain systemic treatments that you can make at a location that has no crashes in its history, that's absolutely fine. But especially if you're going to be spending a lot of money on a spot location, you want to make sure you're spending that money at a location that has significant risk. And usually that is a combination of crash history and kinetic energy risk based on the speed and the angle of collisions, and that kind of delta V change of velocity when those crashes happen. So yes, we do include crash history. That was the beginning of this, was looking at what the probability of a fatal or serious injury happen is, what the probability is of a fatal or serious injury for all kinds of scenarios, and then working that into the process. But it does have crash history, and we're looking at a longer crash history, because one problem that people have had with crash history is you're only looking at 3 years, and if you do that, you have a long story of an intersection, and you're pinching it down to a small amount of time. And especially once you get into rural areas, crashes are less frequent. If you're in a big city, you're going to have a lot of locations that have several crashes a year. But some of our worst locations on our network are less than 2 crashes a year. You might have 8 crashes in 5 years, but because of the way that those crashes are happening, the angles and the speed, and so in some ways the number of fatal and serious injuries, that might be one of our highest priority intersections, and we do have some examples of that.
You brought up rural areas. Most of Maine is very rural. It's like rural Florida, believe it or not, is very, very rural. This approach is crucial for rural crashes specifically, because they are random and they're scattered. You don't find hotspots. So talk to me about, in a very rural state, the importance of this approach.
Right. In rural areas, it's very hard to find hotspots and total crashes. And that's what historically we had done, is we had something called high crash locations, where we look for 8 crashes or more in a 3-year period. And we looked at the rate of crashes compared to other intersections, and if that crash rate was high enough. But that, every state has a different traditional high crash location process, but that process scanned over a lot of intersections that just didn't meet that minimum crash threshold, as I was mentioning. There's several intersections where we've gone out and done improvements recently based on this method that they never have been a high crash location. But as you mentioned, they're spread out. They're less frequent. It's okay if you've only had 1 crash a year, but that crash is a 45, 50 mile an hour angle crash, and you have, especially if you have some history to go with that, where there's been some severity in the past, that might be a really, really high priority location for improvement. It might be higher priority than this location that has 12 crashes a year at this urban signal, where the kinetic energy is much lower, where there's kind of stop and go rear end collisions that have a very low crash risk or fatal and serious injury risk. So it's very important in rural areas, and if you use this method, you can find hotspots. There are locations where people are interacting and either where they're colliding relatively infrequently, but frequently enough with the relational risk of that crash that it becomes a high priority.
That, and what you just said is great. It's a more sophisticated analysis than just looking at raw numbers of crashes at locations, right? I mean,
right.
It's a more complete story of what's really. I like that you use that word, story. It's a story of an intersection. So talk about how this approach is a much more detailed and true story of what's going on.
Right. So it is a much more detailed story. So traditional network screening. So there's been a lot of network screenings that have been out there in addition to just the high crash locations. We have a highway safety manual screening method that, what actually went into that on a location basis is what you had the attributes of the intersection, the predicted number of crashes, and then what we used from observed crashes, we used observed total crashes in a 3-year period, which that, again, as I mentioned, that's a very small part of the story of the intersection. And what I mean by that is I think we had a benefit in many ways from being a small state and having a small staff, because the same people that are doing the network screening were doing the individual site analysis, coming up with countermeasures, drawing plans, and then going to towns and speaking to them about the intersection and about what we're proposing. And when you do that, you hear things from town and you realize you poke some holes in the process that we had. So, there's an example of a town where we went to where we actually expanded from 3-year crash period to 5-year, and part of that is being the rural state and the infrequent number of crashes. It's really just not enough 3 years a lot of times to get the full picture. And really, when we look at ped and bike crashes, or when we look at fatal and serious injury crashes, we really want to look at a 10-year period. And you might say that things changed in 10 years, and that's certainly possible, but the risk of those crashes are so high, the importance of those types of crashes are so high, and they're much less frequent than the property damage crashes. So we need a larger time period to see that. But we have a story. We went to a town, and we're looking at this intersection. We have a crash diagram, a collision diagram in front of them. We're telling them about the crash risk, and they bring up, hey, there was a fatal crash here like 8 years ago. And what we've been trained to say is, oh, that's outside of our analysis period. And if they push you on what has changed since that happened, most of the time you really don't have a good answer. Maybe we made some improvements, maybe we put up a second stop sign, or we trimmed a branch that's since grown back in 8 years. But unless you're making dramatic changes to the intersection, if you're changing the way the vehicles interact, if you're changing the intersection control, if you're able to dramatically reduce speeds, not just changing the sign, but getting people to go slower. If you do things like that, major reconstruction, sure. But when you look at a whole network estate, we have around 34,000 intersections. 99% of the time, probably, nothing of that significant variety has happened. So we really wanted to consider that longer story, the full story of what's happened at the intersection. And diving deeper into that, we're not just looking at those situations where someone actually died or where someone had a serious injury at the intersection. We're taking a look at the risks of the crashes that did happen. So one of the first things that practitioners do, that we do when something shows up in traditional network screening, we have the total crashes that go in, compare that to predicted crashes, or we looked at that high crash location situation. The first thing we'll do is we'll pull out the crash diagram or the collision diagram, and we'll say, okay, what's actually happening here? And what we've done is we've actually pulled that crash diagram, the crash patterns that you see there, into the analysis process. So what we did is we took all of the types of crashes that you'll see in a crash diagram, and we quantified the probability of each of those crashes leading to a fatal or serious injury. And it's very simple. That's just overall, get a large sample size of the number of crashes. For example, rear ends at 45 miles an hour at a normally controlled intersection, or right angle crashes at a signal in 25 mile an hour area. All of those types of crashes, we took the total number of crashes and divided that over a long time period of the number of those crashes that led to a fatal and serious injury. So we have a fatal and serious injury percentage for everything. And then you look at that crash diagram, and you can sum up that fatal and serious injury percentage of everything that's happening and roll that back out. And then that is a big portion of our value for the screening. So you're getting a peek to that next step in the analysis ahead of time and working that in, because there's some locations that will show up on traditional screening. You look at it a little bit closer, and then you don't see really any concerning patterns. There might have been a fluke that led to this, or it might be, those are low-speed stop-and-go crashes. It's not something that we're really concerned with. Or you might see something, hey, those people are colliding really fast at right angles. This is a very concerning intersection. And what we did was we tried to build those kind of alarms that we see in that analysis and that thought process into this. And another thing we do is we look over many years, and we look at the fatal and serious injuries that have happened, and that's kind of a straight face test kind of control for that other process. So we have a quantification of the crash diagram or the crash pattern, and that makes up most of this. But we also have a weighted history of fatal and serious injuries that have happened there, and that accounts for some things that we can't quantify in the data necessarily. Like, maybe they're hitting at a right angle, but it's a little bit off to askew, and it's not really showing up in the diagram. Or maybe it's a 35 mile an hour posted road, but people are going 50, and over time those are going to lead to more severe injuries. So the things that show up at the top of our screening have both concerning crash patterns in that diagram and a history of fatal and serious injuries.
And so this is coming to this. You're describing this.
Yeah.
But you presented, did you present this that got their attention?
Yeah.
Yeah.
The whole slideshow. Yeah.
Yeah. So this, what you just present, the K&A potential screening is what you're talking about here. That it's that much more complete picture. Tell me the story of this sort of project here.
Sure. So how this started was there's a lot of ways. It was kind of 4 or 5 years of working with all the steps of the process, as I mentioned, going to towns, talking to them, doing site analysis, and taking all the lessons we learned, taking some screening methods that we learned from other states, and trying to pull that into one process. So one thing that we did was, the first thing that we did was we compared angle crashes and across the whole state, all intersection types, and we just controlled speed limit. And the first thing we did, this was a year or two before we created the screening method, and we said, hey, every 5 miles an hour that we increase 25, 30, all the way up to 55 miles an hour, every 5 miles an hour we have a higher percentage of those crashes leading to fatal and serious injuries. And we started to work that into our process even before we had a complete network screening. We went to an intersection in Warren where we're proposing a roundabout, and there's been 2 K&As there, but we could tell them, looking at this diagram, the way people are hitting each other in this 50 mile an hour location, we're actually lucky that there hasn't been more K&As. So that was the beginning of it. And then you get into how we actually decided to do this. How do you compare a location that has 5 angles at 50 to a location that has 12 at 25? And then how do you compare those to a location that has 40 rear ends or that has 2 pedestrian crashes? And the way that we decided to do that was to do that probability of a K&A happening or fatal and serious injury happening, and then add it all up so that they're all combined in one system. Because before, what we started to do was we had separate ranking lists. We had a ranking list for the most pedestrian crashes and bike crashes or active transportation crashes. And then we had an angle crash list. We had a ran stop sign list. We kind of had all these things separately. And then we would filter by speed limit. So there was some locations, even though we were doing the right thing by looking at those high speed angles, there were some locations that show up very high on the list that we really weren't getting because there was a ton of right angles happening at 25 or 30 miles an hour. And that actually does add up to a lot over time. But what we do is really, instead of taking that fatal or serious injury that happened, we take that probability as a decimal. So if you have a pedestrian crash and in this location there's a 17% chance that that's going to be a fatal or serious injury, we're not taking the binary yes it happened or no it didn't. We're going to say that was 0.17 fatal and serious injuries. Or we have a rear end that's a lower risk, that's 0.02, and then we add all that up, and that's how we are able to look at all of these different problems, combine them, and kind of rate them the same way, and look at many different problems that are happening on our network and prioritize them together.
That's a great way to describe this, because even me reading this a bunch of times, I'm trying to like that, taking all of those very different ways people can be hurt at an intersection,
Yeah,
and somehow putting them into one big formula. Right? Say we're going to figure all this in and look at total risk.
Yeah.
That was great. Okay, because that helps me even to.
Kevin really didn't understand what.
I was like, yeah, right. I read this in the car on the way over here this morning, right?
It's very simple when you break it down that way. But yeah, things were in silos before because we were doing a lot of these steps. But if someone came to us, and this has happened, and you say, what are your 10 or your 25 or your 50 intersections that are most concerning or that have highest risk? We didn't have an answer before that we felt confident in, and we given an answer based on critical rate factor, which is, it sounds like it has severity in it, but it's really just advanced crash frequency rate. That really didn't tell enough of the story that we felt confident that we were giving the press or whoever was asking the prioritized list of locations that needed to be improved. So I felt like we really needed to get that. And we also, not just a ranking order, but a quantification of that, where you might have a location that has a risk of 2 fatal and serious injuries over the next 10 years and compare that to a location that has 0.2. Not only is that 2,000 something in the ranking and 40, but we know that this is 10 times worse. It's not just that it's worse, but it's dramatically worse, and that really helps us determine the risk of, say, walking away from a project, changing the scope. The town pushes back. There's political pressure, or the cost is increasing. Can we really still justify this project? There gets to be a point where there's such a risk that we can't afford to walk away without a solution going forward. And this is helping us get to that point as well.
It's almost a theory of everything for intersections, right? It's
Right.
much more complete. So kinetic energy and folding that in specifically to this analysis.
Right.
Talk about, one, why it's important to factor in kinetic energy and how you all did it.
Right. So when it comes to kinetic energy, as I mentioned, a lot of states are familiar with this theories. A lot of safety engineers, most safety engineers will understand that hitting vehicles that hit each other at, direct angles, direct collisions, right angle, head-on, things like that, tend to be more severe. They understand the basic physics of, if they're moving together and they collide, that change in velocity, the relative velocity is not going to be very high. But if they're at a right angle, if they're coming together, those velocities are going to combine, the forces are going to combine. It's going to be higher risk to the occupant of the vehicle. Just speaking of vehicular crashes. So people understand that from a crash diagram, and there's collision diagrams and crash diagrams, and then there's also conflict diagrams where you start to look at what's the potential ways that people could hit each other, and you get into crossing conflicts, emerging conflicts. This is great, safe system approach stuff that's been done in other countries that some states are working into their systems. But what this really does is it takes that level, what are those crossing conflicts, and then where are they actually leading to crashes over time. So it layers in the crash history in that kinetic energy diagram. And it's important because we understand that there's dramatic difference in risk to the occupants in those different angles that they're colliding. So we were actually able to dig into the details of the police reports for crashes and actually pull out some of that angle of collision stuff. So not only did we have the speed, which we've demonstrated already was a major influence on crash severity and fatal and serious injury percentage for angle crashes and other types of crashes like pedestrians, like bicycles. But then we could figure out where those are actually leading to crashes at intersections that are at those angles. So we have an intersection movement crash type, and that was one thing we were filtering on before and we were using for a ranking system. Overall, it's a very good system. But we had one intersection that was high in this intersection movement ranking, but where they were colliding was actually emerging conflict. A vehicle was turning left and another vehicle was coming in this direction. They were colliding in a way that was not close to a right angle. And if you look at the injury percentage at that location over time, it was around 10%. And it was really, in a way, interacting the way vehicles do in a roundabout. There's low risk in that situation, and we wanted to find a way to build that into the process so we don't have to correct for that later. So what we found was in our crash data, we have most damaged area, not just on a crash level, but on a vehicle level. So you can see each vehicle that's in a crash, what was the area of the vehicle that was most damaged in the collision. And some other states like North Carolina have talked about frontal collisions. So that was the first thing we looked at. We said, okay, of these intersection movement, angle of some angle type of crash that's going on in an intersection, how many of those was one of the vehicles, the direct front of the vehicle was the most damaged area? And I was surprised to see it was just over 50% of crashes. So it was a really large sample of the crashes. And when I looked into correcting for speed, when I looked into the fatal and serious injury percentages of those, it was those frontal collisions of angle crashes were 3.7 times more likely to lead to a fatal serious injury than the ones that were not. And that just bringing that in can dramatically change the prioritization of these locations. And digging into that a little bit further, one thing that we observed over time is we, hypothesized that vehicles that hit the driver's side tend to lead to more fatal and serious injuries. And the logic behind that is There's always an occupant in the driver's side. There's not always an occupant in the passenger side. And when you get hit as a driver on the side of the vehicle, there's very little area to absorb that energy. A lot of that is going to be passed on to the occupant. Front of a vehicle, of course, head-on collisions are very severe, but the front of a vehicle, you have a lot of deflection area with the hood that's built in, where some of that energy can be absorbed. But on a door, there's very little that you can do to protect that person, because there's very little area between where that car is hitting the vehicle and where the person sits. So what we found is the drivers within those frontal collisions, they were 35% more likely to lead to a fatal and serious injury if it was on the driver's side. And you might think, okay, is that a fluke? But safety engineers know when you look at a crash diagram, you see patterns, you see crash patterns, and you see ways that vehicles are hitting each other over time. And it may be as simple as there's a sight distance problem to your left. You can't, when you're coming from a stop sign, you can't see the car coming, and there's a lot of interactions where vehicles from the side road are pulling out and getting hit from the left from vehicles on the major road. So there is patterns where driver door is more likely than others. So we built that into the system as well.
And a more sophisticated, it's almost like, maybe I don't know the right way to say it, but in my mind, it's like video games. In the early days of video games, everything was like super pixelated, like real blocky.
Right.
And now they look like real life, right? Does it get more higher resolution? You're getting higher and higher resolution on all of this, what's actually going on.
Sure.
Because you have higher resolution of what you see there, you can be more sophisticated with the countermeasures that you choose. So if it's a speed thing, like we were talking about that intersection where we saw the near miss, that's a speed problem, right? You're not going to put a roundabout there, but you need to control speed. Whereas we shot roundabouts where sometimes changing the angle and speed, so talk about how this sophisticated story of these intersections helps you rank them and then also choose the countermeasures you're going to put there.
Sure. And I'll dig a little bit deeper into the system itself and how it considers the ways that vehicles interact, because the energy, the kinetic energy that's happening at a free-flowing intersection is very different than at a roundabout, and that's a simple one that all safety engineers know. Vehicles are interacting at 15 to 25 miles an hour at friendly angles. With the curbing that's done, you basically can't interact at a right angle in a roundabout if it's a single lane roundabout. So the vehicular crashes, it's interesting. We did this, like I said, for every intersection type, and we controlled every crash type, and we controlled by intersection type. So we looked at our modern roundabouts, which we have around 30 of, a little over 30. And we looked at 10 plus years of intersection movement crashes at roundabouts where they were, where vehicles were colliding in the circulatory roadway. And we had over 560 crashes of that type, and 0 of them over 10 years led to a fatal serious injury. And that risk is really not exactly 0, but it's very, very, very low. Compared to an intersection movement crash that's happening, at 45 miles an hour, potentially at a right angle. We also built in, traffic signals. We started to look into a couple of years ago, and we see that the way vehicles interact with traffic signals are significantly different. Much more rear ends, much fewer angles. But even when those angles crashes happen, they tended to be slightly less severe than the free-flowing intersections as well. So we built that in as well. And the rear ends of signals, I mentioned stop and go. The rear ends at traffic signals were very, very low risk. And when we looked at this, it was less than 0.25% of those were leading to fatal and serious injuries. And rear ends at traffic signals were dominating the results of some of our network screening because there's so many of them. But really, they should be considered very, very little. We don't ignore them. We're adding up that small percentage, and if there's 40 of them at an intersection, it might be significant risk. But we're looking at these and considering them appropriately. There's certain crash types, even angle crashes. You have a low-speed angle crash that's happening at an angle that's not a right angle, and you have a 55-mile-an-hour right angle driver door side collision. That higher speed right angle crash is actually 25 times more likely to lead to a fatal and serious injury than the one at low speed at friendly angles. So just building that into the process helps you appropriately look at things in a way that agrees with what we know to be the real risks that are going.
It helped the ranking and then, choosing the appropriate countermeasure because you have a much better sense of what's going, weighting these things, I think is a big part of it. You mentioned that. I like the way that's said. It's like, not all, just looking at raw numbers of crashes, you can get an intersection with 30 little fender benders that everybody gets mad at each other, but nobody dies.
Right.
Versus over here, 3 crashes, but everybody dies. And all those are different things.
Right. And that, looking into how are we weighing these different things at an intersection, we have a tool we made where it will look at an intersection, it will add up this risk for all the different crash types, and it'll tell you which type of crashes are the real problem or the things that you should focus on for countermeasures. And there's 2 examples that are really good for this that are right in Augusta, right near our headquarters office, where there's number 1 and number 2 historically for a very long time in total crashes. They were old school traffic circles, rotaries that were built in the 1940s that have always had problems. And they have 50 to 60 crashes a year, a lot of crashes. So when you look at a 10-year period, they're close to 600 crashes, which is crazy. That's really high for Maine. It's very, very high from a crash rate perspective, from a crash perspective, and those always went up to near the top of our list in our ranking systems in the past because of that. But as I mentioned, the roundabout, the vehicles interacting in the roundabout itself are very, very low crash risk. And these are relatively high in our ranking, not because of the vehicular crashes, but because of the pedestrian crashes and the bike crashes that are happening. So Memorial Circle, one of those 2 old rotaries, it has over 550 crashes in a 10-year period, but it has 9 pedestrian and bike collisions for people that are traveling around the edge of the roundabout, and that added up to over 50% of the risk at the intersection. So that's when it starts to get into countermeasures. What are the things that you're trying to fix at this location? This can help you, look into that further and say, yes, there's another 550 crashes that are happening here, but the most impactful thing we can do is pedestrian and bicycle improvements, which is that goes against what most people were trained to think. And there was another intersection that we were looking at. We had an example that we showed in Bangor where a ton of signalized intersection rear end collisions and 1 pedestrian crash. And that 1 pedestrian crash was over 6 times, had the fatal and serious injury probability for that 1 pedestrian crash was more than 6 times the probability of all the rear ends added up at the intersection. So again, when you're going to look at countermeasures, when you want to make a difference in fatal and serious injuries in your state, this will help you prioritize what you want to do at an individual location to make that difference.
That's a good way to say that. Prioritizing the serious ones, and even one of these can count more than 20 of these other ones.
Yeah.
Very good. I'm going to ask you one technical question, then it will go to this sort of broader, where do you see this going from here, and where are you applying this in other areas?
Right.
Just to get it on camera, explain to me what delta V is.
Right. So the delta V is the change in relative velocity for vehicles that are happening in a collision. It's really kind of a physics way to look at an intersection. So we're trying to not just use mathematics to approach our network screening, but we're trying to use physics theories as well demonstrated scenarios that we know are likely to lead to higher forces for vehicles, as I was mentioning with the driver door earlier. And when you have 2 vehicles that are colliding at an angle of 15 degrees in the same direction, the relative velocity, the change in the velocity between the 2 vehicles is going to be very low. It might be, even if they're going fast, it might only be 10 or 5 miles an hour. And the direction that they're going, the forces are mostly going together. They're working together, not against each other. Whereas if you hit at a complete right angle, that vehicle that's going at a high speed that's hitting the side of the car, it's getting that side friction of the tires. It's getting the vehicle that's coming with it. They're going in complete perpendicular from each other. They're not working together. That's going to be much greater forces for the occupant of the vehicle that's hit and for the vehicle that is hitting them with the front of their car. And that gets even worse as those vehicles start to move into each other. So if it's a head-on collision, of course, there's a lot of energy going into each other. If you're hitting a tree or a ledge and you're coming to a stop with no deflection of the thing that you're hitting, that's going to be a lot of energy for the vehicle. And the same goes for a vehicle that's turning left from the side road, that's hitting a vehicle that's coming on. And those are some things that we could only get so far with the crash data, and that's why we included the weighted K&A history in there. And I say weighted where we consider things that happened more recently higher, but we're still considering things that happened even more than 10 years ago for fatal and serious injuries. And one way that we see that coming into this process is you see something that has more K&As than what the crash pattern would indicate. And you look at it, you say, oh, these vehicles are actually hitting each other at a way that they're moving into each other. It makes sense that these crashes are more severe than we would have thought.
And so, yeah, I mean, if you're going from 30 miles an hour to 25 miles an hour, and you're both going the same direction, it's a different thing than going from 50 miles an hour to 0 miles an hour.
Yeah,
like that,
yeah, exactly.
That's the delta V, right? Like that.
Right.
That difference from speed to no speed translates into power that you're hitting human beings.
Right, exactly, and that's the case it gets into these angle crashes really well. We have a situation where at an intersection in Damariscotta where it's a 55 mile an hour road, people are really going more like 60 miles an hour, and they're hitting at that right angle. So the forces involved in that crash are taking the free-flowing vehicle down from 60 to 0 in a split second, and they are coming to a full stop, and they're not traveling very far once they hit each other in that intersection. So that change in speed over a short time and a short distance leads to a lot of forces and a lot of risk to the people that are in the vehicles.
Because that energy is going somewhere, and it's going to go into that human being.
Exactly.
More than likely. Good. So this kind of thinking, this much more sophisticated and detailed analysis, this project was specifically at intersections, and it's helped you prioritize them and rank them differently than you would have in the past, and apply your money in a way. Let me ask you about that. Is now that you have this clearer picture, how has that helped you make investments? Because you're doing 30,000 intersections in a small state, you can't do everything everywhere.
Right.
How has this helped you justify how you're spending taxpayer dollars?
Yeah, we've really started to. First of all, the easiest thing to do is to try to find effective countermeasures for the locations that are at the top of the list where we think there's going to be 2 or 3 or at least 1.5 fatal and serious injuries in the next 10 years if we don't come in there and do something. That's the lowest hanging fruit. And then once you go beyond that, we looked at the previous projects we had that we felt comfortable with. A lot of those were in kind of the top 500 in the ranking list. And we said, okay, these are significant risk, because not every location is going to have an easily implementable countermeasure to solve the problem. A lot of them will, if we're willing to change the forces and the kinetic energy and the way people are interacting, because we are kind of aggressively using always stops in our state. We went and we looked at always stops. We controlled for that, and especially if you can get people to stop at the stop sign, the kinetic energy and the way these vehicles are interacting is very, very low speed, and it's not as good as a roundabout. But roundabouts in this state take several years to go from idea to deployment, and they cost a lot of money. We just have one that's proposed that costs $4 million, whereas always stops, we have a safety project where we purchase flashing stop signs and stop ahead signs in bulk, and we deploy them to several locations. So we're able to work with our maintenance forces, work with towns and cities that are interested in making these improvements, and we can make an always stop happen a lot of times for less than $20,000 in some cases less than a year. So that project delivery to come in and make that dramatic change, you can see in the system when you change a location from other intersection control, a free-flowing intersection, to an always stop control, you can see immediately the crash risk and the fatal and serious injury risk goes way down. And if you think about the way vehicles are interacting there, If everyone happens to stop at a stop sign, most intersections are not that big. By the time they hit each other, it's going to be less than 15 miles an hour. And in most cases, especially for occupants and vehicles, that risk is going to be really low. So you might look at a crash diagram at an always stop and see a lot of angle crashes, and you might be concerned. But think about, what are the forces involved in that crash? What we did find is where you have problems with people blowing through the stop signs, those angle crashes are more than 6 times more likely to lead to a fatal serious injury than the ones that are not. And that makes sense. That's logical when we think about it. So what we're trying to do is doing everything we can to, when we make these conversions, make sure people aren't blowing through those signs. So we're putting stop bars and stop pavement markings and stop ahead pavement markings, and we're putting flashing stop ahead signs and flashing stop signs on the new stop approaches, usually on the left side and the right side, depending on sunlight availability. But a lot of ones we've been deploying in the last several years have been changing the energy that's happening at the intersection, changing the way vehicles interact, and we're doing it at relatively higher speeds. We're doing a lot of these at 45-mile-an-hour intersections where traditionally, some states would think that's not safe, but we're seeing major safety improvements when we're doing that. So that's one way that we're implementing this is we are proposing roundabouts at a lot of these locations, but those take time to come in, and they cost a lot of money. We're finding a way to make a dramatic improvement in a short amount of time with always stops. So, you mentioned that this is only an intersection tool right now. So, of course, there's ways that we can tweak this, we can perfect it, we can make it slightly more accurate. But we did look at this, and we looked at it compared to our other screening methods, our historical screening methods over the year 2023. We looked at where all the fatal and serious injuries happened at intersections, what was the related ranking for those intersections in these lists, and then we looked at, what about the top 10, the top 100, the top 1,000 locations that were ranked? How many fatal and serious injuries happened at those locations? And across almost every single one of those metrics, this new system won and predicted the best location. So it's not perfect yet. It's simple math done many, many times across the whole state. But we're at a point where we know it's better than what we had before. And we're happy with that. So we can work to tweak that, and we probably will work to make it better. But another thing that will be a big thing we can do is we want to build this into an automatically updating system where it's in our network, where there's low data maintenance. That's one thing we want to do. Another thing we're going to want to do in the long term is we're going to want to do this for road segments and streets as well, because you really just have to go through that upfront legwork to quantify what's the probability for all these different crashes, and then it's just adding it up. And once you get road segments and intersections, you can start from point A and point B and add it up, and what's the risk for this whole thing combined. And that would be a major tool for corridor analysis, for kind of grant application situations. So having that street segments, long-term road segments would be a major improvement, because then we can get into things like lane departure and what are those risks, which is a big problem for rural states.
Yeah, I was thinking about lane departures. I do a lot of work. That's a big part of my work I do with SAWA with roadway departure, especially rural roadway departure.
Right.
Yeah, which is like 40% or more of fatal crashes in every state in the union. Like everywhere.
Very high for us.
Yeah, everybody has this problem. But
yeah.
So that's really good. Anything else I haven't asked you about in this whole story?
Yeah, well, more things that we're doing for implementation is we're taking, in addition to the network screening side of this, we're taking the things we've learned through this process, that most of these crash types we can clearly demonstrate with our own state's data that the severity of these crashes are increasing as the speed limit is increasing, as the vehicle speeds are increasing. So we're working that into a lot of our systems, and one thing we're doing is a major overhaul of the way that we set speed limits in the state. We're considering the roadway context, and we're looking for situations for, especially in areas where people are walking and biking a lot, we know that those risks are relatively much higher and that those risks increase as speed increases. So we're looking for areas where we think, based on the level of development in the area, that we should have lower speeds here, and then we're doing combination of speed limit changes with speed management countermeasures to actually lower the speeds and lower that risk. And then on a countermeasure basis, We are looking to change the intersection control, but that's not always the best solution for an intersection when we do an evaluation. So what we're trying to do in other situations is we're trying to lower the speeds and lower that energy baseline that's going on. So there's one location where we're proposing, speed tables and raised crosswalks where there's angle crashes and a pedestrian problem where, we might not be able to completely solve all the problems at the intersection, but we'll take that 35-mile-an-hour collision, we'll bring it down to 20, and we're going to see a major improvement. There's another situation on a high-speed rural road where we have, people going 55, colliding at a right angle, but it's a hard place for a roundabout because you're in the middle of a curve, and it's not going to meet any signal warrants. So what can we do? Well, we're thinking about doing things like chicanes to maybe bring that vehicle down from 55 or 60 down to maybe 40 miles an hour, 35 miles an hour, and just lower that risk. But the big thing is, they had those plots, those diagrams from Safe System Studies internationally where you can show how the fatal and serious injury risk changes with the speed limit for all these different crash types, fixed object crashes, head-on crashes, pedestrian bike crashes, angle collisions, and we've been able to demonstrate that that's true in our state. And now that we've been able to verify that, it's really working its way into a lot of our systems.
That was a beautiful way to finish that up. Yeah, that's good. By the way, just as a guy who I work with the National Center for Rural Road Safety, so rural is a lot of what I work on specifically. And so I have kind of paid attention to that. My wife and I have been driving up and down things. So y'all done a really good job with like nice retro reflectivity, edge lines,
right?
Center line rumble strips, chevron signs on a lot of the curves. Well, these are nice curves. Matter of fact, we were going through some curves at night, coming back from wherever we were coming back from. And I almost asked my wife to take a picture, and we were going through it, and, didn't want to, stop or anything, but I'm like, this is like a really good, because it was nighttime, and nobody has the pictures of nighttime. They're always out during the day. I'm like, this looks great. It's a nice clean edge lines and nice chevrons going around the curve. I'm like, this is really good.
Right, right. Yeah, we're probably going to get into a lot more of the rural road segment along the roadway countermeasures once we get more knowledge about where these locations are highest risk. But it's true that the intersection countermeasures, like always stops and roundabout, they're just so proven and they're so effective that we have a high level of confidence when we put those out there that we're going to walk away and we're going to dramatically have changed that situation. It is harder in a lot of cases on rural road segments with signing and markings and widening the road, all these things that we can do. We know through studies that they've demonstrated to reduce crashes, but it's not necessarily going to reduce K&A risk by 90% like some of these are. So it's harder to attack the road segment, the rural travel between locations, between intersections, but that's where the systemic safety improvements have to come in, or the systematic improvements like wider use of rumble strips or low-cost countermeasures applied over many miles of road. I think that's probably our best way to handle that.
For sure. Yeah, there's no equivalent to the roundabout in a rural roadway departure. It's just like, rumble strips and water edge lines and nice shoulders and stuff like that. But anyway, clear zones, when you can, when you're not in like Montana where it's like, or parts of Maine where it's just like it goes straight down.
Right.
Make a clear zone, you're going in the water. But anyway,
right.
Well, this was great, man.
Okay.
Thank you very much to give us.
I am rolling.
Good. All right, just say and spell your name just so we get a sound check.
Yep. Jeff Pulver, Jeffpulver.
Good. All right, cool. You're rolling, so I'm just going to leave you to it.
Okay, sweet. So we're out here in this beautiful rural area in Maine. Tell me the story of this intersection right here.
Yeah, so we're at the intersection of Route 133 and 156 called Beans Corner in Jay, Maine. This intersection has been a problem for a really long time. People knew that there was crash issues here. This one wasn't a secret. But this is a challenging location. It's not very high volumes. It's way less than what would meet a signal warrant to put out a traffic signal. You've got a very long vertical grade, about 5% grade on the major road here of Route 133. And nobody wants to stop or slow down traffic on a really challenging long grade like that, especially where you're in the mountainous area, you've got a lot of snow. There's a lot of challenges. It's not easy. But this, when we did our network screening with the kinetic energy, this was #1 in the whole entire state. And the reason for that is this was #1 in right angle crashes. There's a lot of intersection movement crashes, and almost every single one was right angle. A lot of them are hitting the driver's side. And the posted speed limit of Route 133, the major road, is 35 miles an hour. But when we look at the information a little closer, we see people are really going 50 miles an hour. So they're 50-mile-an-hour direct hits. Another challenging thing with this location.
Start over with the speed limit. Like you say, it was 35
Sure.
miles an hour, but they
Yeah.
were going, just in case
Yeah.
his brakes were screaming.
Yeah. The posted speed limit is 35 miles an hour here, but when you look closer at the information, you see people are really going 50. So it's 50-mile-an-hour, very high speed, right angle crashes, dead hits, a lot of energy, a lot of force on the drivers that are involved in those crashes. And another difficult thing about this location is we've been here before, we've done things, we've made improvements. So it's hard to go back and make more improvements when you've already done things. But once we did this and we found out it was the top of the screening list and we could quantify it, we could say, we believe to our best judgment, we think that there was going to be a rate of 3 fatal or serious injury crashes per 10 years here. That was enough for us to say, this is too high of a risk. We have to act, we have to find a solution. And although nobody wants to stop people with all these trucks on this, yeah. Nobody wants to stop people on the steep grade with all these trucks. It's not easy to do, but it was important enough that we had to do a solution. So we haven't always stopped. Thanks to our traffic and our maintenance forces and Dennis's help, we were able to do this within a year. Almost immediately after we did the screening, we came out, we talked to the town, and we have a solution, interim solution in the first year. We have a roundabout programmed here. Again, it's challenging to design a roundabout on a steep grade, but this one warrants it from a safety improvement more than any other intersection in the state.
And so this one was a pretty obvious one because they had so many crashes. But this also, the reason it ranked #1, that idea, which is the crux of the story, of incorporating kinetic energy into your analysis is what really made this thing shine. So talk about how incorporating that kinetic energy consideration made this a different analysis than it would have been in the past.
Right. This one had a lot of crashes given the volumes here to begin with. So there's only about 3,000 vehicles out here on the major road. It's not a high volume area. So the crash rate and traditional metrics would tell you that there's a lot of crashes here. But how do you separate this from other intersections?
That was really good. So start
Yeah.
that thought over because that's where I want you to go. All right,
Yeah.
you're good. The cars don't
Yeah.
matter so much. It's
Yeah.
the truck.
So under traditional metrics, this intersection was already able to be identified in some way. You could see that there was a lot of crashes, especially given the relatively low volumes here at this intersection. But how do you separate that from all these other locations that have a lot of crashes? For example, there's a lot of signals in urban areas that have 30 plus crashes in a 3-year period. And how do you look at this one and justify that this is that much worse? And that's where the kinetic energy comes into this. When we see the angle of impact,
That's the loudest camper I've ever heard in my life. All right.
yeah,
So you
yeah,
start that, not the whole thing.
yeah,
That was really good.
Yeah.
But this idea of it was able to,
Yeah.
a traditional urban
Yeah.
intersection is going to have more total crashes, but
right.
that idea.
Yeah. So how do you separate this from all the other locations that have 30 plus crashes? Because in urban areas, there's a lot of signals that have a lot of kind of stop and go rear end crashes. And that's where the kinetic energy comes in, because we see that the crashes that are happening here are almost 100% high risk crashes. They're all, right angle, direct hit. The force of that vehicle going down the hill or flooring it up the hill is going right into the driver's side. There's very little deflection area for the car to absorb that energy. It's just going to go right into the driver or into the passenger. And there's a lot of force involved. In the stop and go traffic, the delta V, the small change in velocity, we're talking about people that are going 5 miles an hour or going just a couple miles an hour less than the people in front of them. Here, they're going 50 miles an hour and they're coming to a direct stop almost immediately hitting these people. So that that pattern combined with the fact that we know there's been 5 serious injury crashes here already in the past 20 years, it's very reasonable to estimate 3 in a 10-year period going forward. It passes the straight face test. And with that knowledge, we know that that's just so much more than most intersections in the state. We're in the top 0.001% of intersections here. And with that knowledge, we know that even though we've made improvements here before, we have to come back, we have to do more, we have to do something significant, not just that's going to lower crashes, but that's going to be changing the way that vehicles interact, lowering the energy, and making them interact at pedestrian scale, having them cross each other at 15 miles an hour. And we're very confident that we have both a short-term and a long-term solution here that will solve this intersection.
Cool. So what are some, not the first time you came out, but this latest round of things you've done here, what are some of the countermeasures you've done here?
Yeah. So the long-term solution here we have is a single-lane modern roundabout. But roundabouts take a long time to design. We know that. And because of the urgency that we have, knowing the rate of serious injuries and the number of these angle crashes that are happening every year, we really wanted to get an interim measure. So we have an always stop out of here. And this is one of those situations where you're concerned about making sure the people on the major road stop when you make the change. So the major road, which is the one that's perpendicular behind us, that one has flashing stop signs on both sides, flashing stop ahead. It also has the stop bars, it has stop pavement markings, it has stop ahead pavement markings. We also have additional traffic calming speed management in advance. So we knew that people were going 15 miles an hour plus over the speed limit. So we have these kind of triangular chevron shaped speed markings. What are they called? Optical speed bars. We have these optical speed bars that are chevron shapes in the road that they get closer to make drivers feel like they're going faster than they are so that they can adjust their speed. We also have 35 mile per hour pavement markings. So just in case they don't see the sign, it just reinforces that right in the roadway in front of them. There's already a beacon here. They had to change the lens of the major road so that the beacon is red. So we've got all kinds of countermeasures here in the short term. And this is all setting things up to calm traffic before, so when we build the roundabout later, we're not dealing with a situation where they're going 55 and then having to come to this roundabout that's a surprise.
So have you been tracking, this is all relatively brand new, but have you been tracking this long enough to have any kind of after data?
No, right?
Not yet. It's still too new, right?
Yeah.
Brand new.
Yep. We just finished this in April, or is it recent than that?
Yeah,
July.
Very recent.
Well,
you can tell.
Yeah. This was just completed in the last couple months, so we don't have any
Based on
after
your
data.
observation standing here, though, I know
Right.
the two of you were kind of watching
Right.
this and how people are behaving.
Yeah, I mean, you can stand here and you can watch the vehicles that are going behind me, and most of them are coming to a complete stop on the major road. On the minor road, we also installed these flashing signs that you see because there were people running the stop sign, and that can sometimes lead to even worse crashes before. But Dennis and I, when we got here, this is the first time we've been here after it's been fully completed, and we can see, just like when Casco is completed, vehicles are slowing down. They're, by and large, they're being compliant with the stop approach, and if they happen to go through, they're rolling through at 5 miles an hour, which we know that that's not that concerning. If vehicles hit each other at 5 miles an hour, there's not going to be severe injuries. So, but we're very happy with the results that we've seen so far. We hope this pans out over a 2-3 year stretch where you start to see some AFR data with some significant results.
It's a great way to help these less obvious areas. I mean, I know this particular one was pretty obvious because of the number, but ones like this help them bubble up into because this is a problem all rural areas have.
Yeah.
So trying to compete with big cities and places where it's just like, your crashes happen in onesies and twosies out here.
Yeah, I mean, for sure, the crashes that happen in areas like this and situations like this, there might be fewer of them. This situation happened to have a lot. There might be fewer crashes, but the consequences of those crashes, because of the forces involved, are much higher. So we have a few locations that have less than 2 crashes a year, even less than 1 crash a year in some situations. But the K&A history combined with the kinetic energy involved in the crashes that are happening shoot those up towards the top of our list, and we want to react to that appropriately.
That was it. That was perfect. That was it, man.
Good.
Thank you.
So when we came here a couple of years ago looking for an improvement, this was the #1 location in the state for right angle crashes at 55 miles an hour. And obviously there's a lot of force in that situation. And now that we've done this, we've created the screening method. It was actually in our top 10 in the whole entire state. And with that, we can justify there's enough risk here that we can't do any more tweaks here. We have to do what's going to be the actual solution that's going to solve this intersection once and for all and save people alive.
And before with the traditional screening methods, this would not have made the cut.
This was on and off a high crash location. It was kind of on the fringe. Total crashes, it's not that high. It's just barely meeting our traditional high crash location, as well as our excess crashes, excess crash cost. It was moderate. It was relatively high, but it wasn't to the point where we could justify a major multi-million-dollar improvement. It wasn't until we started to look into that kinetic energy stuff, like the number of true right angle crashes at this speed, which is really about 60 miles per hour out here. We used that logic. We figured out the likelihood of fatal and serious injuries happening here, and that's where we decided we have to do the big solution. We have to do a roundabout that we proposed here to make the big difference.
That was good. While you're talking about that, we can hover the drone over that and superimpose a roundabout. Yeah, I like that.
That's all I needed. I just wanted to say, yeah.
That's it. Yeah, that captured it all.
Yeah.
So in the 38 years in your career, I don't suppose you worked in safety that whole time.
No, my first 12 years were spent in highway design, and then the last 25 and a half have been in traffic engineering. So.
Okay, traffic, yeah.
Yeah.
So good. So thinking specifically of safety, and this, you and I talked about the systemic approach that you all take. That's a relatively recent thing, right? In the last few years to start thinking that way? Or how do you all incorporate that?
Yeah, before they came up with the buzzword systemic safety treatments, we were doing, things like RFBs, giving RFBs out to towns where when I first started putting in RFBs to get them installed and put in, they were costing like $20,000, for a set installed. And I found out I could buy a set for back then around $4,000. So the rest of that was installation and markup. So we started thinking, what can we do to get a better bang for our buck? And so we looked at giving RFBs to the municipalities. Their cost share would be the installation piece. And they weren't paying $16,000 for installation. A lot of times it was probably another $3,000 or $4,000. So, that it was a better bang for our buck, and we were getting, far more of those out there. Every year I go to a trade show called ATSA. I can't remember. It's American.
American Transportation or Safety.
Yeah, but
I know ATSA.
So their convention is, they have a floor, about the size of a super Walmart, and all the vendors are out there. And to me, it's invaluable to be able to go and talk to those vendors. And from talking to those vendors, that's where we got the ideas for the speed feedback signs. That's where we got the idea for the in-the-road pedestrian signs, because we give those out. The school zone signs with the speed feedback sign in them. Those are all ideas that came from going and talking to people on the floor. And honestly, what I do is every time before I go to that show, I pull out a strategic highway safety plan and I read up, and then I'm like, okay, I'm going to if I find something that fits, make a play for money on that. Here's, if somebody shows me a solution that's a good solution, then I'm, open to us spending HSIP money on that. So then I talk to Bob and Dennis, and we talk about, how can we make this fit and get the biggest bang for our buck. So we were doing systemic type treatments before, the buzzwords really came out. So.
And you're doing some of that kind of work. This project is more about the intersection work that's
yes.
going on. So tell me what's going on there.
So we've had problem intersections, in the state for a while, and what do we do with them? We got some, that have a lot of angle crashes. they don't have the volumes that would meet a traffic signal warrant. And when you look at the warrants and the METCD for an always stop, sometimes those volumes don't quite meet what we have out there. But because of sight distance issues and crash issues, we've kind of melded that a little bit, and we kind of bend that a little bit to cure some of the problems we're having out there, because the traditional fixes just wouldn't work, or, it's not a place that we'd want a traffic signal. So, that's allowed us to really dig in deep on some of these things where we've had a lot of K and A crashes that wouldn't have risen to the top for other reasons. And when you start talking always stop, at $6,000-7,000 an intersection, it's a huge bang for our buck. North Carolina has done a ton of always stops, and we really kind of mirrored their program. They did it with all the bells and whistles. They just went in and put up stop signs out there. I was very leery of doing that. We have long tradition of years people going through an area. Just sticking up a stop sign, I wasn't comfortable, having that be the solution. So putting ones with the flashing LED borders and putting stop aheads with flashers also, really to call attention that there's a change out there. Now, after those signs wear out, I'm not looking to go back and replace them with flashers, but, until people get used to it, for me, it's worth that extra money to know that I've done what I can to get people to stop. And we've been very successful with the program. I think out of all the ones that we put in, we've had 2 intersections where we've had one each where we've had a pretty significant crash because somebody ran through the stop sign on what used to be the through. Then we go and take a look at it. What can we do to make that more conspicuous? And in some cases, we've added more pavement markings, just trying to call people's attention to what's going on out there. I think people are doing a lot more things other than driving. That's been a huge problem. And while it's illegal to have, talk on your phone and everything's got to be hands-free, you can pull up to any intersection here and look over, and there are people doing things they're not supposed to. So, our chief engineer, coined a phrase is, it's our job to distract the distracted driver from being distracted. And, that's unfortunate that we've having to, get to that level, but that's pretty much all the things why we're doing things with the flashing signs, really to pull people back to pay attention to the roadway.
Are you involved or know how these intersections are prioritized, like which ones they're doing? Because that's part of what Jeff and all them were doing with that analysis. Is you have 36,000 intersections, I've learned.
Yeah.
It's like, as low cost as these are, you can't put them everywhere.
Yep.
So can you talk a little bit about how these are prioritized and how that may be different than they used to do in the past?
A lot of them have come from places that I would call frequent flyers, that we've had issues there before. And those are the real ones that we started with. We've had public complaints. So we already know they want to do something out there. So we chose those first. We had a couple places where, one place in particular where the town didn't want to have something done. They didn't want to do the always stop. About a week after they ran us out of town, there was a fatal crash there, and then they're calling us back. What can we do? And I was like, well, we already offered you the solution. Here's the solution again. Let's go put that up there. We as a department were always kind of afraid of some of the higher speed ones, putting an always stop out there. The one with the fatal was a 55 mile an hour approach, and we introduced a step down speed through there, to get people to, hopefully slow down before they get to till they always stop. So I mean that part's changed in our thinking. Originally we were talking really about doing 40s and 45s. Now that we've done one at a higher speed, we know that we can go out to the other ones. So it's opening our target area to look at that. So where we can pull out where we've had, Dennis Edmondy's been working with the expected versus excess and predicted crashes and coming up with hotspot areas where we're seeing excess crashes out there, and we're using those to to set some of these areas. Also, we're trying to get it in areas. We have a lot of problems in this state with people going out and shooting things because it's fun to shoot things, and trying to get these in areas where there are houses around so that people aren't going to shoot them. I've had message boards shot, I've had speed feedback signs shot, and so kind of balancing where our trouble spots are with where we be able to keep something. I've had lighting sawn down on a rural roundabout because somebody, I don't know why they didn't like it, because there really wasn't a house around that it was shining into, but people do strange things. But yeah, it's focusing on the K's and A's where we're seeing more than should be out there, and trying to target those areas. And it is a tough sell in some communities, and for us to be able to point to our successes that we've had in other areas is important. So.
And I think Jeff was saying getting some really good results. Like I think a couple of these, 97% reductions. I mean, that's
we've had have a lot right in the 90 area, but that's still that's significant. Somebody doesn't have to lose a loved one. Someone doesn't have to spend time in the hospital. I think that's huge. So.
Well, it's life changing, right?
Yeah.
I mean, and to be able to show that you have, so maybe kind of rephrase that or start that thought over, is like, if I were to ask you, what are some of the results that you all have seen from some of the installs you've done so far?
Well, I think it's the reduction in the injury crashes is the big thing. It's hard with fatals. I mean, anybody could die on any roadway in the state. It's hard to predict. You get one in a certain location, you probably never see another one again. So yes, it's great that we're preventing fatals, but I think those are harder to quantify because they're so unpredictable. But injury crashes is a big thing, and if we're starting to see a pattern of injury crashes, that's indicative that's probably going to happen more. So if we hit those hot spots and get those out of there. But it's kind of interesting when you look at the numbers. We've got all these reduction in injuries, but our injuries are still high. So, I don't know how to explain that portion of it. It's just, it moves us to go look at different areas, but
You're
it's
not
tough.
alone in that. There's a lot of states, most states, who've done a lot of the safety work and been working at this, and then their crashes are still going up. And so then you get into the argument with only two ways to see it. This stuff isn't working, or how many more crashes will we have had, right? So that's a hard way to articulate it, is it's like cost prevention type stuff. How much money would we would have to pay if we hadn't done this is tough.
Yeah, no, it just seems like we're running on a treadmill sometimes. We're doing a lot of effort, but we haven't gotten that. We're seeing results in the stuff that we're doing, but when you look at the total numbers, it's kind of discouraging. And then it makes it hard to keep pushing for, hey, we need this money. We can show reductions at spot locations, but we need to do more on the systemic piece. But yes, how many people would have died if we hadn't put an RFB at a crosswalk, or we hadn't lit a crosswalk, or we hadn't told somebody to slow down. We have no idea, what we do on day to day and how that impacts out there. But we just got to keep moving forward, because that's what we're here for. So,
That's it. Anything else I haven't asked you about this project, or systemic approach, or
uh,
that you think it's important for like your peers? Because this is for people like you out in the range.
yeah, a lot of people are doing things with road diets. We have a road over in western Maine, Route 4, it's in Turner and Auburn. We've had a lot of crashes out there. And on the southern end of this corridor, we have a 4-lane section coming into a 3-lane. And, we're going to look at making that a 3-lane. And there's a huge area out there that's control of access. So there isn't need for people turning or whatever. We're looking at installing cable guardrail in the middle of the road, similar to what we're doing in what they're doing over in Europe in a lot of places. And, it sounds crazy, but we need to try different things in order to get people, attention. And that project's going to allow us to actually cut some pavement out, excess pavement, which is going to save money further down the road and what we got to pave, but it'll also slow people down. And, we've always been about mobility. And when you look at our design practices, it's all been for mobility. And I think that's what's gotten us into the issues that we have. And we're not the only ones that are seeing that is, how do we balance mobility and safety? And that's gonna.
And primarily mobility of cars.
Yes.
And we talk a lot about, that's every town in America, right?
Yeah.
We built our towns around moving the cars.
Yeah.
And so that's what's gotten us here.
Yeah.
That's why now we're having to undo infrastructure to then redo it for pedestrians, bicyclists, that's not you only, that is everybody.
Yeah.
That's where we live, it's everywhere.
That's a huge change for a lot of designers who are like, no, the mobility is important, speed's important, and it's hard to start pulling the reins in, and you start doing things to decrease mobility. It really sends up a red flag with some people, so it's hard to get buy-in.
People in the towns, they're used to being able to drive fast on that road.
Yep.
We have one in our town right now that's a giant, it's a range war. It's this beautiful scenic area. It's 1.8 miles. Everybody loves to drive, and the roads are as wide as an interstate.
Yeah.
It's crazy, and it's just through this little residential, and they're trying to narrow the lanes, put in a multi-use path, and you'd think we were burning their houses down.
Yep.
Like, don't slow me down, ever.
Yeah, no, Jeff talked about town Vassalboro. He said the tubular markers out there that was slowing people down. We did one similar last year in town, and the complaints that we got were these things are too close together. I have to slow down to go through it. I'm like, that's why we're doing it, and they just don't. It's impacting me negatively, so it must be a bad thing. So
We have our
that's
Main Street and our historic downtown, they narrowed the lanes, took the parking from that kind of herringbone to parallel, widened the sidewalks, complete streets stuff, really nice.
Yeah.
And that was the thing. I have to drive so slow going down Harrison Avenue now. You go,
Yeah.
right.
Yeah.
Or I don't even drive on Harrison Avenue anymore. We go, even better.
Yeah.
Just park. There's so many other side roads where you can get, but they, it's so funny that they don't hear the words they're saying out loud. It's like, yes, they're offended that they have to slow down in a fully, like a little downtown area where people want to
They
shop.
think it's bad design. It's like, no.
Yeah, you guys
That's
screwed up
what
this
we
design.
wanted.
We had to drive so slow. It's like,
Yeah.
that's right. They don't, they don't see it.
Going back to, we didn't discuss really the speed, but 85th percentile, back when that was really, set up, the cars that were on the road, you could actually feel the road. Cars today, with all the safety improvements, you can't feel the road anymore. You have no idea how fast you're going. And I don't think a lot of people are speeding to be malicious. I just think it feels comfortable for them. And we've gotten to the point where we've got to make people feel uncomfortable to get them to slow down. And I'm not saying that we should change the cars and go back, because a lot of safety advances have happened on that, but it's just it's an unintended consequence. And now we've got to do other types of engineering to counteract that, because that's a huge problem. And I find myself doing it. You know, you look down, you're like, oh, I shouldn't be going that fast, and and I had no idea. I was thinking about work or thinking about something that's gone on during the day, and you're just kind of numbing it, and you're like, and that's why we gotta, the whole thing, distract the distracted driver, get something, flashing lights, bring people's attention back.
I like that, distracted drivers from being distracted. Yeah. It's good, I like that a lot.
Yeah. I do too.
This is great.
Yeah.
You're all done.
All right.
Yeah, not so bad.
And roll and you do
Yeah. Okay, so the first thing I'll get you to do is say, come on in. That's perfect.
Oh, thank you very much.
Is to say and spell your name, so the way you want to see it on screen.
Okay. Dennis Emedy, DennisEmedy.
Okay. And what's your job title?
State Highway Safety Engineer.
Okay, sweet. Okay, cool. So as soon as Ray gets the lighting the way he wants,
I just had to creep into the shop when I was adjusting.
it's a pretty wall. That's really nice. It's better than most conference room walls we get. Most conference room walls is like, would you like beige or would you like gray? Would you?
That is pretty impressive, I'll
Very
say.
nice, right? That is really good. Yeah, the blue is a nice color.
Yeah.
Yeah, that's tastefully done.
I don't come in this office.
You're not-
Thank God.
It's probably a good thing.
Yeah, this is cool. One of the worst ones I ever did was early in my career. We were in Kansas City, and I was trying to scout this place, and I was just like, listen, we need a room that's a relatively big room, but quiet. That's the big thing. It's like we need to be near, like away from, like a workshop on the other side of the wall or whatever.
Right.
Okay, we got you, no problem. So we get there. And they didn't have a workshop or anything next to us, but we shared a wall with the hotel kitchen. And so literally I looked in that thing and there were stainless steel utensils and pots hanging from them, like
That's
they
not.
were doing food for the hotel. I'm like, how'd you think that was quiet? This is way better. Are you good?
We're good.
Okay, cool. So, starting at a very high level with this sort of project that you all came into, talk about you talk about this progression that you all have been through. So, talk to me about where you all started in this kind of stuff.
Well, I think it all started with high crash locations. The state of Maine DOT has been using high crash locations, which is 8 or more crashes in a 3-year period with a critical rate factor greater than 1, which is basically you're experiencing more crashes than what you would expect at a similar type of intersection. So that term, high crash location, is everybody knows what that is. It's been around for probably 40 plus years, if not more. And so back in the 2000s, we were introduced to the Highway Safety Manual, which was great because the Highway Safety Manual allowed us to, where you have excess crashes, we're experiencing more crashes than what you would expect, but it wasn't based on 8 crashes in a 3-year period, which came into play when you have a road where there isn't much traffic on it, but it's experiencing more crashes than what you would expect. But it's not a high crash location, so therefore it's hard to justify doing something. So that opened up a whole new world for us with the the Highway Safety Manual, excess crashes, and especially and then when Jeff came along, we were doing we were looking at crashes. The Highway Safety Manual was great, but we would evaluate some places where there are excess crashes, and at the end of the day, we would have different potential projects. and we would kind of look at each individual, which one should we prioritize? You know, of course, we base it on the highest safety benefit to cost. But and Jeff was able to, you know, well, we should have this one higher because it's, you know, just based on the types of crashes and the speeds and the injuries. And so it kind of went above and beyond the highway safety manual. And Jeff, in his brilliance, was, you know, able to look at all these different intersections and put them in spreadsheets that, you know, was just way beyond my ability, you know, being an old timer. But you know, so he was able to develop, you know, what I knew from experience, he was able to put in priority. And so that's how he kind of, you know, put a value to experience. That's the way I kind of look at it.
Or quantify it.
Quantify it, yes. Quantify that, you know, yeah, we should do this intersection first because there's a lot of angle crashes, there's a lot of injuries compared to an urban section where there's a lot of rear ends or something. So, yeah, so I mean, it was really his idea. You know, and the only thing I ever did was just allowed him the freedom to explore and grow, and that was kind of my that's all I did.
That's
you
not
know,
nothing, by the way. That's because a lot of bosses wouldn't.
Right.
I want to hear that, like you said. This is not how we do this.
right?
But total crashes are not total crashes are not total crashes. That's the thing, right? It just the raw number of crashes. And like Jeff was saying, you know, you can have 30 rear end crashes, which is property damage only, versus 2 pedestrian crashes, but they're both fatals. Those are different things.
Exactly.
And so it sounds like what you all have a much more sophisticated view or a way to look inside those numbers and add this other layer of analysis, which is severity and kinetic energy and the angles. That's the key.
That is, yes.
So how's that changed your approach to prioritizing your money and your countermeasures and how you do projects?
It's significantly improved the way we look at it. And it also helps justify doing something versus not doing something. When it's ranked, you know, 11th in potential fatal and serious injuries, you need to do something. Doing nothing is not really an option. And, you know, as I talked about earlier, we have a lot of opposition to certain projects. And knowing that there's likely to be a fatal or a serious injury, we really need to do something here.
And before, you weren't your engineering judgment, like your gut, would probably say something bad is going to happen there one day, but you couldn't prove it.
Quantify it, yeah.
And so,
Yeah.
tell me how that feels to now have that validation of your engineering judgment and experience, but you can show it in an analysis.
It's great. You know, it's just the progression, like I said, from high crash location to the highway safety manual to this new methodology of Jeff's, you know, potential fatal and serious injuries is just, I think it's wonderful.
And so a big part of your focus now is implementing, like getting the countermeasures on the ground. So talk to me about some of the specific countermeasures you're installing at these intersections and why.
When we look at, when we identify the locations, you know, we look at different countermeasures. You know, we look at, you know, we evaluate things on a safety benefit as well as a mobility benefit. And we'll look at, you know, an all-way stop. We could look at an all-way stop. We could look at a traffic signal. We could look at a roundabout. Different, and what we do is when we look at these different alternatives, or changing, you know, a skewed intersection to a T, you know, teeing it up or splitting the intersection. You know, we'll look at these different alternatives, see what the safety benefits are for each alternative as well. You know, we'll look at the mobility impact, but the safety benefit is much higher in general than the mobility impacts. But we'll look at it all, and you know, based on, you know, the available money, the incremental analysis of, you know, roundabouts are very hard to meet the safety benefit for, even, you know, and when it meets a benefit for a roundabout with the incremental analysis of, oh yeah, it costs a lot more money for a roundabout, you know, is the incremental analysis justified for spending the extra money for a roundabout? Because, you know, roundabouts are, you know, ideal for the kinetic energy and reducing that kinetic energy, as well as an always stop. We're finding that the always stops are we're finding fantastic results of the always stops, conversions from two-way to all-way. And a lot of times, you know, where we're looking at rural intersections, they don't have the volumes for a signal. And so with, you know, and when we look at an all-way stop, the safety benefit is so high, the cost is so low. I mean, we have generally like 100 to 1 benefit to cost ratio. And thankfully, we are able to install these always stops with our maintenance forces. If it doesn't require any special treatment at this intersection, we do it with our maintenance forces. And I draw out, you know, our section draws out the plans. I go out in the field, lay out where the sign should be, and I do everything out in the field. And you know, we estimated roughly about $20,000 for an always stop. And you know, what we do might be a little different from other states is that we put in the solar LED signs for 2 stop aheads and 2 stop signs, along with pavement markings, you know, stop ahead, stop bar, stop stencil. And oftentimes people complain about them, you know, going in, they're not ready for them, but as soon as they go in, the phone stop ringing for the most part, which is very good.
And just one of the great benefits of this analysis and this more sophisticated approach you're taking is a more systemic deployment of these low-cost things. So instead of, you know, you can go around and spread out a $20,000 intersection treatment over lots of intersections and have 100 to 1 benefit on. That's good. That's great news.
Yes.
So talk about the ability now, based on this analysis, you have the quantified to go, okay, this is where we should put these low-cost treatments, and we're spreading them out instead of just chasing crashes and doing hotspots along the way. So talk maybe the idea, because the systemic deployment of low-cost treatments, just like you described, is a relatively new way of looking at all of this, isn't it?
It is. I mean, it is. Yeah, we've put a lot of always stops in over the last few years, and I mean there had been some in the past, but now we'll, you know, given the data that we have within our own state and national studies, that we're putting in some always stops where people would, you know, probably never would have thought before.
That's what I mean. Is that it's letting you, based on data and choices, where people you're doing them preemptively, right? Like proactively. You're getting out there. You don't wait for somebody to die to make a treatment.
Right, right, and yes. yeah, that's what we're trying to prevent is someone dying. And yeah, I'm just thrilled at how effective they are. Of even this, a simple $20,000 fix. And I don't know if I mentioned this, but we purchased the LED signs through HSIP funds, and then, like I said, our maintenance forces install them. And it's a little challenge though to get this, the sign crew out there, the striping crew, the stencil crew, the flaggers, all there at the same time. So it is a little, it is a little challenge to get everybody, because maintenance forces are very busy themselves. But we went out to bid on some of these projects, and it was just like, instead of $2,000, it was like almost $200,000 to put in an always stop. Just doesn't make any sense, so.
So you mentioned as a guy who's been around a while, kind of an older dog who's come out of this, but you've seen the Jeffs of the world and seeing the direction this is going. Where do you see all this going? As a guy who has a longer perspective than certainly Jeff, who's very young, looking at this, sort of thinking of where you started your career and where this is going.
I mean, when I first started, I didn't even have a computer at my desk. Okay? When I started in highway design, I didn't even have a computer on my desk. And what Jeff and OIT has been able to do is put all these crashes and all this, the HSS, we call it a HSS, the Highway Safety Manual, put it all on our network, so people can see it right there in Map Viewer. Now Jeff is able to put the K&A on there, and I'm able to, putting it all on the computer, putting it all on, you know how long it takes to do a roadway segment using the Highway Safety Manual? It takes a very long time, and we've been able to automate it so you can just say what point A on route 111, or to point B, where do we have excess crashes along this route? Where is that? And it's amazing. What took hours is now minutes. So we're going in the right direction, and as far as putting this all in all this data, all these numbers, so that people can visually see what's going on. Where's the hot spots? You could easily see where that is.
That was a great way to say that. What used to take hours now it takes minutes. Yeah. That's a nice closer to the video.
Yeah, it's
Anything I haven't asked you about this work, or about, like, if you had a peer, somebody like you in another state, in Nebraska or something, what would you tell them about this process? Who maybe is not as far along as you all are.
I think what separates Maine from a lot of other states is that we do have the crash data. We know where crashes are. We know where they are. Every crash that's in the state of Maine is located by people in our section. And they read the police report, they get the description, and they mark it right in the network. We're very, very fortunate that we have this crash data. Many states don't. And I think that's what separates having the crash data, the roadway data, is sure, there could be always improvements to the roadway data, but we have something, and that allows us to combine the crash data with the roadway data and have the ability to use these high, better way of analyzing what's going on. I mean, I'm very blessed that we have, again, that we have the crash data, and that's a priority, that we identify where those crashes are, and that we do get another person in our section make sure, like, why is this, if there's a department that doesn't seem to be having crashes, they'll contact them. It's like, you seem to be lower than normal for crashes, and we have that working relationship with the police departments and state police and stuff like that. I think that's where Maine is very fortunate.
You are, because we work with states all over the country. That's a struggle. It's like they say all this data analysis is awesome, but we don't have the data, or we don't have great data, or how can we work better with law enforcement and EMS and even schools and people who know they're on the ground. They know where crashes are happening that might not be reported, especially in rural areas.
Right.
People are going to run off the road, go off into the trees or the cornfield or whatever. They aren't going to call the cops. They're just going to drag their truck out of the ditch and call their buddy with a winch, and
Right.
some of the stuff is just you have to get on the ground to really know where things are.
Yeah, and we hear that once in a while, like, hey, I had this recently. It's like, this curve is really bad, and it's like, our data's not showing it, and that's exactly what you were saying, is that they, but, the fire departments were called out, and so they had that record. So, but there wasn't enough to bump it up
Yeah,
to.
so you are very fortunate, because a lot of states struggle with it. Even way bigger states than you struggle with it, especially if they're in their more rural areas. It's just harder to capture that stuff. But good. Anything else I haven't asked about, or this is?
No, I
You just did your first interview.
thanks.
You still breathing?
No blood?
No blood? Like,
No blood. No, no. It's just yeah. Like I said, we're very fortunate to have this great data. We have a great relationship with OIT to, what we've done on horizontal curve stuff, and it's amazing. It's truly amazing. I hope Jeff shows you the graphics, because to me a picture says a million, says 1,000 words or whatever that saying goes.
it's on our list for him to show that.
Yeah, because you see, when you see little red dots on the map, okay, there's a problem there, and nothing like a red dot,
Yep. Especially when you know that the data back it up, like this, like he was, talking about this sort of, it's almost like an equation of everything. It accounts for all these different things and weights them differently, and like that's super advanced.
Right.
Did you said you go in and talk to people that are gonna implement this stuff? Like you go in and talk to commissions
Yeah,
and
to like
city
towns
managers?
and-
Oh yes, I talked to the towns.
How long have you been doing that?
Too long.
So is there a difference now? Like when you go into them now and you have all this stuff that you can show them, is there a difference?
Oh, yeah,
Well-
yeah, so
I think on I don't get into the details with them, because they wouldn't understand it anyway. You just have to talk very simple language as much as possible. If you get into, this is, get into the highways, no one's going to understand that. So the trick is to
translate it. It's a translation.
to make it as simplified as possible, but without getting into too many details. And that's a challenge. That's a big challenge to
And then we got to be frustrating because you have the data to show what you're doing.
Yes, and it can be frustrating when they say, "We don't care what your data says. That's not going to work here." And it's like, and then you have to show them examples. And there's nothing like giving somebody examples. It's fine to give them examples, nationwide studies, but when you have the data in Maine They know the intersection. Hey, this used to be $4 million worth a year in crash experience. Now it's down to $150,000 in crash. I mean, just it's great to have. And the hard part was getting the numbers for in-state. Having those first few sites, and that was getting the results in Maine makes a big difference. So. Yosemite, we're in Casco at the intersection of Route 11 and 121.
Check levels and then we'll you're good to go. Okay. So tell me about this intersection. What's the problem here?
This was a high crash location that had had a long history of being having a crash problem, and this is our first modern always stop that we installed, and
Reservations about it.
and we this was our first always stop. There was a lot of I had little concerns about it, putting in an always stop, but after watching the traffic, after it was installed and watching the traffic, I was converted as to how well the traffic behaved after changing it from a two-way to an always stop.
Because the fear was they weren't going to stop. They were so used to going so fast here, right?
Right. The fear was that the cars were going to continue at high speeds through the intersection, but with the flashing stop aheads and the flashing stops on both sides of the roads and the pavement markings, the people that didn't have the stop before were stopping fine.
You have a fire truck going behind you. It's like perfect. So do you have data on this
Yes.
after data?
Yes, we do have the data.
So what was the situation here before? I don't need exact numbers, but it was pretty bad. This was top of your list, right?
This was like one of the top spots in the state where,
All right, just not that dump truck is a little bit too loud.
Jeff, do you remember the numbers?
Don't worry about so much about the numbers, but this one, when you did your network screening, you did the network screening after this, right? But you say this, if we had this would have ranked very, very high in your network screening. So
We had 5 K&A crashes. 3 of them were just before this.
Yeah, this is a site that had had 5 K&A crashes before the change, and after we converted it, there was just property damage and 2 people complaining of injuries. So the crashes have drastically reduced.
and the severity of the
And the severity of crashes.
This one was the big number was
This,
98% reduction in crash.
Okay.
okay, 98. I couldn't remember. I have it.
Yeah, so I'll tell you what, because we had a few
Yeah.
big trucks go in a row.
Yeah.
If you would start that kind of thought again, say before we had 5 K&A crashes, and then after this we've had a 98% reduction in severe crashes. Even that idea is such a big deal.
Yeah. Before the conversion, there was 5 K&A crashes. Afterwards, there's been a 98% reduction in crashes, and we've seen the crash cost go from $4 million to less than $200,000 for the 3 years afterwards.
Good. That audio, I mean, yeah. If we could try that thought one more time simply because of the trucks, we're trying to time it.
Yeah.
Cars are okay, but dump trucks,
This is saying, Dennis, the crashes were going down 98% with the cost, right? The severity and the
I don't remember. I have it written down, but I just.
I just looked at it yesterday.
It's totally fine.
Yeah.
Well, you can, even if,
Because the crash is reduced and the severity reduced, the crash cost reduction is 98%.
yeah.
Found the owner of the cigarettes.
I didn't hear what you said. Jeff, I didn't hear what you.
Okay,
I didn't hear what you said, Jeff.
that's okay.
I'm saying just because,
You go through this, huh?
Yeah.
I'm just saying because the
This was one of our worst intersections before we converted. There was like 5 A and B, 5 fatal and serious injury crashes before. And due to the reduction in crashes and severity, we've seen a 98% reduction in crash costs at this location.
That was good.
I'm gonna let this go by, and then I have one more thought I want you to.
You can go up there so it's easier to hear.
This one's not going to be numbers. It's more like what we were talking about over there. To say, hey, Jeff and I came out here before. This was one of our most dangerous intersections, and we did this treatment. But when we came back after, like this changed my whole view of four-way stops because we could see the traffic was responding so well. So just that kind of thought.
Florida.
I left the cigarettes in it. Yeah. Okay. I think it's just cars. So at this point, so is it that idea that this is one of our worst intersections, but when we came back out here after and we sat here and watched it for an hour and we saw how traffic was responding, that changed my whole view of these four-way stops.
Say that one more time. I'm sorry.
It was just like we were talking about over there, where you said this was one of our worst
Oh, yeah.
intersections. But when we did this treatment, and we didn't know if it's gonna, how well it was gonna work, but we came back out here, we sat here for an hour and watched traffic,
Yeah.
and it was responding. It's like it changed my whole view of these things. Yeah.
So like I said, this was one of our worst intersections, and when Jeff and I came out and watched the traffic for about an hour, this changes my whole thought process on always stops, and the traffic behaved so well with the change from a two-way to an always stop. Oh shit.
We can use it. We can use it.
I
Try to mitigate the background.
Because this is
but-
not gonna stop. I mean,
No,
as
it's
soon
just-
as I,
Right when you started getting good, that truck took off. That one came in.
that was great. He nailed it.
Yeah, you nailed it.
but every time I think we have a break, we end up
Yeah,
with
let's
some
just try
intro.
one more time and then we're done.
All right, let's do that one more time. That thought, and let's just see if we can. Yeah, but that was it's fantastic.
You're good.
This is one of our worst intersections, and once it was converted to an always stop, Jeff and I went out and observed it, and it totally changed the way I look at always stops, and I was amazed at how well the traffic behaved afterwards.
My name is Julie Kaiser. Keizer is the last name, and Julie is the first name.
And what's your job?
I am the town manager in the town of Waldeboro, Lincoln County, Maine.
Very cool. Okay, so we're standing out here like a bunch of crazy people at this intersection. Tell me the story of this intersection. Why are we here?
So there were 4 dangerous intersections in Waldeboro when I got here in 2017. This intersection of Manktown and Union Road, or Route 235, was the most dangerous intersection of the 4. We had many fatalities, and when I say many, for a small town, it only takes a few for that to have a great impact on the community. And we had one that was particularly bad with a motorcycle involved. We had some poor visibility with trees. Obviously, there's a change in grade, which makes it hard. I was always told, roll both your windows down and listen. Don't look, listen. I mean, you have to look obviously too, but you also want to listen. So when we had the opportunity with the Maine DOT to fix it, we thought it was a really great idea to partner and make their job as easy as possible. So when the idea of a four-way stop came up, how can we help? And my director of public works, John Daigle, who's been here for 47 years and absolutely hates this intersection, said, well, I think what you really need to do is shave some of the hill off. And that just is so much money. It really is just so much money that it puts those types of projects out of reach for the average community. And the state can't afford to do that in every town. So when they came to us with this idea of the four-way stop and blinking lights, it was fabulous. And we were so excited. To the point where after 47 years of dealing with this intersection, John said, what can I do? So we had an arborist on staff and called Dennis and said, hey, Dennis, we can take down these trees. And we took down a large portion of trees. And then they came in and put up four-way stops. And now we all look like heroes because it works. Not only did it work here, it worked further down the road at Old Augusta Road and Route 220. And that was our second most dangerous intersection. And at first, you know, people get a little, the locals, that's not gonna work. You know, that's something from away, but it worked perfectly. And now people love them, absolutely love them.
So what was the condition before? Like, what was, there was a stop sign here? Like, what was going on here?
So right here was going on was you stopped going, I'm going to say
That way.
south.
Just like that
I'm
way.
going to say south. So you would stop just like this van is stopping, but I don't know if you can see the truck.
Go ahead and stand right there. Yeah, stand because
Okay.
you in the, otherwise, yeah, there you go.
This truck coming at us would not have stopped. So it was only a two-way stop over a busy road. And what's happening here is there's an incline and then there's a hill here. So you really couldn't see. When you pulled out, you're looking both ways, but sometimes they hid in the hill. And then they'd pop up and they'd be there and you'd be like, oh my God, there's a car coming. And in all honesty, I almost got it once here because even though I had my windows rolled down, it was an electric car and they don't make a sound. And I almost got hit here.
And they're moving on this road without a stop sign, I imagine going well faster than 50 miles an hour.
So that's one of the problems we have in Maine. People speed terribly. And I think it's all over. But to me, it just seems like in the last 10 years, speeding has gotten worse and worse and worse. So although it's posted at a certain rate, you can count on about 10 miles an hour over the speed limit. And we live in a very rural area. And people like their loud music and their jacked up trucks, and they might drive a smidgen over the speed limit.
And so this stop sign helps with all of that because it stops them, but it also lets these people have a chance to breathe.
It
and
lets
see.
them breathe, it lets them see, but it actually has helped the speeding in this general vicinity. Now I'm getting requests for all the people on Facebook, because you know there's Facebook warriors, and I'm sure you see them all over the place. I have some especially amazing Facebook warriors. I did not realize they all went to traffic school to be engineers.
Civil engineers. Yep.
Totally did not understand that, but they educated me on it. Even those hardcore people who thought they knew better, now they're like, oh, we should do this at every intersection, to the point where our remaining dangerous intersection that we're working with the Maine DOT on, there is an actual incline, and in the winter, I think it's a 13% grade. 10% grade. You obviously can't stop a big truck in the winter on a 10% grade, and we can't build a shelf for it to sit on. So we're working with them, and everybody wants a four-way stop there. And so it's really caught on in our town, and we are so blessed and thankful that the DOT worked with us. And I just love that spirit of cooperation. And you know, I've been doing this for, I'm in my 38th year in municipal government. And I started out in New Jersey as a town manager, and I came to Maine. And one of the big things I notice is in New Jersey, all the federal money that the state gets goes to the big cities. So I was the town manager in very rural communities. And we had situations just like this that could have been solved by this very thing. But we'd never see the money because we're too small. And if you're not getting the volume, it's hard, but our severity, I would argue, was worse. And it's just different how Maine does it than how New Jersey does it. And I'm asked that a lot, is what are the differences? I think this is one of the most wonderful differences between New Jersey and Maine, is that I can call up anybody at the MDOT and they actually answer the phone. I call them my 3 Ds. There's Dave, Dennis, and Daryl. And I can call them up and say, hey, we've got this issue, and they're responsive. And I think part of the reason they're so responsive is that they have the backing of the federal government to say, hey, you know, we can use these funds to help you solve this problem.
So defining this problem, because they do, they say, yeah, we'll help you solve that problem, but people like Dennis and Jeff have to justify that. They can't say, trust us, we need help over here. They have to quantify that somehow. So some of the very innovative stuff they're doing is they've actually figured out a process, and I've seen that this big spreadsheet.
They do.
That if you can put in a spot, it will weight the severity of your crashes against the number of lesser severe crashes and weight them, so this actually ranks and merits spending.
It does, and I'll tell you what was really great is they actually came down with all their bells and whistles and numbers, and Jeff, I think we may have called him a geeky numbers guy.
He brought a bag of money.
But when he explained the numbers to us, it made sense to even me, who is not spatially or statistically gifted at all. So if it made sense to me and he was able to make it make sense to me and convince our 47-year public works director that it could be accomplished by stop signs, that was a feat in itself. So the data that they collect when they do the survey, and then when you actually see it brought to life with all the turning components, because you'll see how many times somebody turns left or somebody turns right, and also the speeds at which they're going. We're also blessed, we're unique here in Waldoboro because we have full-time EMS and full-time police. So sometimes you don't have that in Maine because it's very rural. But we're able to give pretty good crash data to the MDOT when it comes to the crashes.
You are blessed to do that. We do this all over the country. So I was in Denver recently, and we were looking at maps of Utah and western Colorado, looking at just mapping where are the EMS, because if somebody does get in a severe crash, you want them treated within an hour. And some of the level 1 trauma, there are no full-time EMS. Everybody's a volunteer out there. And it was something like 5 hours to the nearest trauma. Like,
well,
you're done if you're out. You know,
we are very blessed. It used to be that way. It was very volunteer based up until about 10 years ago, and that changed. But one of the other things in working with some of these other intersections is we've involved our director of EMS, so he can actually speak to the severity of some of the injuries and to some of the crashes, along with our chief of police.
So how does it feel as a town manager to how you sleep at night a little bit better, knowing this thing is better?
So I'm going to tell you 2 stories about that. When I first got here, a gentleman lived on 220, which is where the old Augusta Road intersection is. He came to me on my first day of work and said, we need to do something about this. And it felt great. It was one of those things that I was tasked with as the town manager by my select board to say, you need to work with the state to fix these. So it's something we could cross off the list. On a personal note, my daughter and her 3 children, ages 7, 4, and 2 years old, moved on to Old Augusta Road. And every day she travels that, and she would go through that intersection. And I feel better as a grandma and a mother knowing that I believe truly in my heart that, my children and my grandchildren are safer because the 4-way stop is there. Do you want me to take that?
Do that thought?
Do you want me
Let's
to
redo that
redo it?
thought again.
Okay.
Yeah.
That's
No,
what I
it's
was
fine.
like.
You weren't hearing anything, but she kind of stopped and looked
Yeah,
at the camera.
but that
Okay.
is a lovely,
That was a really nice
lovely
soundbite.
thing. Yeah.
Okay.
Yeah, I would love to do that again.
Yes.
I can do it again.
Yeah.
Not a problem.
Talk about your grandbabies. No big
Talk
deal.
about my grandbabies. I
Yeah.
can do that all day. So, on a personal note, one of the most important things to me is my daughter and her family, a 7-year-old, a 4-year-old, and a 2-year-old, moved into Old Augusta Road. And at that intersection of Old Augusta and 220, that's an intersection they cross every day. Not only with my daughter, but on their school bus. And I can tell you, I sleep much better knowing that they're safer and everybody else is safer. And it just takes that little bit of worry off. Not that you still don't have to be careful, but I'm just happy that it's fixed and everybody's a little bit safer, because you don't think it matters. Well, it's just one intersection. But when people have been hurt there, it matters a lot. And another story that we had, a woman who did lose somebody there wrote us a little note on Facebook to let us know that she is happy that no other family would have to go through that tragedy. And that meant a lot to us too. So it makes me feel good all the way around.
Excellent. I'll get you to say and spell your name.
Sure. Robert Skehan, Skehan.
Okay. And you want Robert instead of Bob on screen?
I'd like probably Bob.
Okay. Yeah, very good. Bob's can do that. And what's your title? What's your job?
I'm the director of the Office of Safety and Mobility for Maine DOT.
Sweet. Okay. Head of the Office of Safety here. So Maine is a small state. It's a highly rural state. So talk to me about some of the sort of high-level safety challenges you all have around the state.
Sure. Well, we have per capita a pretty high number of centerline miles for the population that we have to support it. From a safety funding standpoint, I think we're the 4th lowest HSIP fund recipient. There are 4 states lower than us, plus the District of Columbia, most years. So we've learned over time to be very cognizant of our fiscal constraints and try to do the most that we can with the monies that are available. And that basically makes us need to look at specific areas to make sure we're having the highest impact that we can within our fiscal constraint.
And so the way that you're doing it, specifically with some of the work that Jeff and Dennis are doing, is, and other states too, by the way, because everybody has limited funding. Right?
Sure.
Everybody has way more lane miles than they can really handle. You all even more so. So choosing where to put that money to get the most safety benefit, the most data and sophisticated analysis you can do to choose those locations, the better, right? I mean, you're always trying to find how can we really quantify our benefit.
Absolutely. We're advocates of the safe system approach. We recognize that it definitely is a shared responsibility for all of us to do the best that we can. And we all, have recognized that kinetic energy plays a huge role in the severity and outcomes of crashes that we see on our highways. Being a largely rural state, our biggest killer and creator of serious injuries are lane departure, but that following close behind is intersection crashes. And so we use a variety of tools to look at and rank the potential for crashes, both looking historically at what's happened, but also what predictive methods we have to look at what might likely happen based on roadway features that are there and present in the infrastructure. But still, with 36,000 plus intersections on the public highway system in Maine, we need to look at multiple ways to pare that list down to meet our available funding. And so Jeff came up with this particular method to focus specifically on fatalities and serious injuries, that we use in addition to the other tools in our network screening to do data-driven safety analysis.
Everything you just said, FHWA is going to love. Like you hit all the safe system approach, kinetic energy, data-driven safety analysis. Like this is the data-driven safety analysis team is the one who sent us here. So they're going to love everything you just said. Like that's exactly what they hope everybody says.
Yeah, I saw the other videos. So.
Oh, you watch the other ones. Okay, so you
Yeah.
see the gist. Okay. So then based on this work that Jeff and others have done, how has that changed your way of ranking and prioritizing locations?
For the most part, the results that we're seeing, and now we have a dashboard that actually shows all of the intersections, with a style that allows us to quickly identify those with the highest K&A potential. Really what it's done is, in many cases, it's confirming the results and concerns that we've identified through our other tools. So it's just another tool in the toolbox to allow us to look at how our other tools are functioning. So there's been that benefit. But it also allows us to, with the limited resources, we really need to focus on those areas that we can make the biggest change in improving the safety for our travelers.
And for the longest time, this is what Dennis said too when he started his career, is it was data driven, but it was a lot of engineering judgment because you just didn't have the tools and the data and to quantify this stuff. You just sort of knew, so over that time, tell me how that builds your confidence to make these decisions based on, and you can, so like Dennis has to go to public meetings and explain to people why we're putting in this roundabout or whatever, is to, maybe talk a little bit about the value of having these data-driven approaches now that over past ways of doing things that were as data-driven as they could be, but they just didn't have as much information.
Sure. I think it's important I'm a firm advocate of, engineering eyes on the ground. What I really feel the value of the data-driven safety analysis is that it allows us to prioritize places that we need to take a closer look at. We're not reliant completely on the results of the data-driven safety analysis in selecting, which project is going to be put in the work plan. But it allows us to go out and do a more thorough evaluation of what the problems actually are, getting into the details of what are causing crashes there, both from a behavioral and an infrastructure standpoint.
It also sets you up for a more systemic deployment of countermeasures. So because all states around the country, traditionally, it's been more of a hotspot based on crash history, right? We look for hotspots and then we go fix the hotspot. But one, that's reactive. You have to wait for people to die before you can do anything. And then two, in rural areas, that doesn't work because you don't have hotspots. They're random. So maybe talk some about how you've moved into more of a systemic look, the network screening, of course, looking across your network, and then putting countermeasures down proactively before, based on risk instead of based on crash history alone.
Sure. From a rural state perspective, obviously with lane departure being, our most pressing issue with regards to fatalities and serious injuries, countermeasures like rumble strips and edge line striping, the retroreflectivity of striping are our most cost-effective tools to deal with that type of crash, as well as enhanced signage and curve delineation and things like that. When it comes to intersections, things like reflective back plates for signalized intersections and other low-cost countermeasures can improve the safety of the infrastructure that's already there. And so those are some of the things that we look at. We've actually taken corridors that have safety issues, that have multiple signalized intersections, and we've been installing these reflective back plates on a corridor basis and that are currently in the work plan. We have others that will be coming out in the next work plan. So that makes a big difference there. And it's tools like the K&A potential or our highway safety manual screening methodologies that allow us to identify which of these corridors are the ones that we ought to be looking at first.
So it lets you, one, it sounds like it gives you more confidence in your decision making, but it also probably lets you stretch your dollars further.
Yeah, I would say so. Oftentimes, an intersection kind of behaves more, the problems at one intersection are not necessarily, the same that we'll find at all others. Those are really often, unique issues that are there, particularly with infrastructure as old as Maine's highway system. For instance, our network has kind of grown over time from the horse and buggy days. So we will often find in our rural village areas buildings very close to the roadway system. And so the challenges there may be horizontal and vertical geometry. It may be proximity of buildings that are obstructing intersection sight distance. And so that's really where, looking at the history of it from a reactive standpoint, but also trying to move beyond that to, is that historic performance going to continue into the future based on similar experiences or facilities with similar characteristics, to put us in the, I'm not sure how I want to say this. Because I understand we're not really doing a lot of systemic treatments. Always stop conversions is kind of a new one that we're looking at. And oftentimes that's addressing some of these older areas where we have sight distance issues. We have, non-compliance with stop signs for, two-way stops on a high-speed rural highway. And we're finding that, there's a balance to be had there between mobility and safety. But if people can't see the traffic coming, then it might make sense to have everyone stop briefly. So there's a semblance of safety there, but there's also a semblance, the mobility disbenefit, as long as traffic volumes are lower, it makes sense, and they're a very cost-effective treatment for us as well. But really, they are kind of spot improvements when you get down to the details of it, but getting to those locations with the poor past performance and characteristics that are likely going to continue to have poor performance in the future is where our screening tools come in, are invaluable.
Because then it lets you, out of the 36,000 intersections in the state, it lets you prioritize the ones you need to get to first.
Yeah, we're going to probably do 15 to 20 intersection improvements a year with the funding that's available out of 36,000. We really need to narrow our focus, and there's really no other way to do it.
200 years, you're done, right?
Yeah,
That's right.
But I mean, basing it on risk instead of basing it on who's screaming the loudest or what local mayor wants it at whatever. I mean, it's got to be a better way to do the 15 a year.
One thing I've noticed in this job is that a lot of times people perceive the intersection in their community to be the worst in the state. This gives us an objective way to measure whether that's true. In fact, it is one of the worst in the state, or whether it's just a perception. And our responsibility is for all the citizens of the state, so it allows us to fairly assess and allocate our limited funds where they'll do the best, the most good.
So as a guy who's been in your career a while, like Dennis said, he's kind of an old dog here, and you got guys like Jeff coming along with all these new fangled ways of looking at safety and analysis and stuff like that. How do you see the future of this going in Maine, and these new approaches and these new ways of looking at things?
I think I've always been a proponent of technology and leveraging it to the best that we can, from, when I was a young engineer, implementing desktop CAD for highway designers, to asset management systems that allow us to look at the condition of all the pavements in the state, as the highway management engineer in the past. And so this is just a natural extension of leveraging, what's available to allow us to work smarter, not harder. It's only going to get better from here. And people much smarter than I and Dennis will no doubt be able to, and we're seeing it already with our young staff, like Jeff is able to leverage his, familiarity and eagerness to take it to that next level, regardless of, what technology comes out in the future. It's nice to know that when I'm retired that we have young engineers that are going to pick up the mantle, and when I'm old and driving around as a retiree, I'll feel pretty comfortable with the people that we have that are going to be coming after us.
Great way to say that. Because the whole point of this is to save people's lives. It's easy to get caught in numbers and public meetings and stuff like that, but this is life and death, and we all use the roads.
Yep.
Anything I haven't asked you about this project, about this analysis, about intersections in Maine, or to your peers across the country? Because that's who this is for. It's
Sure.
for people like you in other states that are almost certainly not as far along in this kind of thinking as you all might be.
I see most of them every year at various conferences, but I really think that focusing on fatalities and serious injuries and preventing those or mitigating those makes a lot of sense. If you look at the old way of highway safety analysis, trying to prevent all crashes, it's really quite unrealistic. And, it can be a little overwhelming, but if you focus really on those that are going to affect people's lives the most because of severity, then I think you can make a real difference.
That was great. Because you could spend your whole career chasing fender benders, essentially, because there's so many of them.
Right.
And not get down to the ones that really are going to affect your life.
Did Dennis
Or take your life.
talk about one step on the highway safety? We use the excess crash method with empirical Bayes adjustment for our intersections, and we are now developing or have developed at least a prototype for segment-based analysis. But we've also included crash cost in there as a consideration, which isn't part of the highway safety manual. And part of that is because we're a largely rural state. Before including excess crash costs as a consideration, we were finding that that particular methodology was quite biased towards more urbanized areas of the state. But by considering costs, which is, it kind of transferred out, and those results were showing us, some of our rural high-speed 2-lane highways where problems exist there. So you always have to kind of think out of the box and use a standard tool, but think of how it fits your situation, and maybe your state's a little different, and so you really need to adjust on the fly and make some adjustments to nationally accepted practices and standards to come up with something that best fits your situation.
That makes a lot of sense, because in other work I do, also work on a project with the National Center for Rural Road Safety. And a big part of what we do is working, or a recurring thing that comes up is this general pull toward the urban areas in every state, right? I mean, and I know why that happens, and I totally get it. But even coming down to like presentations, you'll see presentations from people at a rural conference,
Right.
and all their pictures are like Denver,
Yeah.
or Chicago, or the Beltway in DC, and you're like, You're not talking like that's telling everybody you don't understand them. You know, it's a different thing, and so you have to. It's one of the things I love about this is you're weighting things. It's almost like the electoral college or something, where you're weighting things on a different. So the underrepresented people in the rural areas can count as much as the people in the urban areas, and you can make decisions on an even scale.
Absolutely.
Yeah.
It makes it an apples to apples comparison. So it would not be responsible for us to spend all of our available safety funding in our urban areas, you know, because we have problems in other parts of the state that those people deserve to have their, you know, their infrastructure as safe as we can make it as well.
And this analysis helps you look at those on a much more even basis.
Absolutely.
Anything else that along those lines that I haven't asked about, or because I think that's revolutionary. I think it's super smart to be able to weight all that stuff and look at it, because I can understand why FHWA is very interested in this.
I think it's important to know that you don't necessarily need a PhD to apply this method. You don't have to invest, you know, tens of thousands or hundreds of thousands of dollars to implement this kind of analysis. We're using Excel spreadsheets, you know, fairly complex ones, but basically if you have access to crash data and to get some critical information for us, like we're looking at angle crashes in intersections and where the impact is occurring in those. Is it in the front of the vehicle? Is it on the driver's side or the passenger side? To also influence the weighting, because those historically, or you know, when you have a frontal impact, you're going to have more severe outcomes. And so, basically, if you have access to crash data, pretty much anybody, a municipality can take it. Certainly, a consultant working for a municipality can implement a methodology like this.
Great message. That's because that's a very common thing. It's like, oh well, we can't, you know, because the way Jeff said it was, this is simple math, just done over and over again.
Right.
So it's not like it's some crazy thing. It's just this. We figured this out, and now we just repeat it a bunch of times.
It's not advanced statistical modeling.
That's very. I'm really glad you said that, because that's going to help a lot of people who are, well, we don't have we're Maine. There's like 4 people doing this whole thing over. It's like if we can do this, you can do this wherever you happen to be. So I love that. Well, this is great.
All right. You got everything you need?
We're not like the nightly news. We're not.
No.